thank you so much for having me today. Really pleasure to be here. Unfortunately, cannot be in person, but I guess that this way we'll have to do. So yeah, I've seen a little bit of part of the last session, which Quarkus was mentioned. So if you only catch up right now, Quarkus is the subject I'm going to talk about. Unfortunately, I could not understand completely the last session because, well, I don't speak German. But at least I recognize some Quarkus stuff that was being mentioned. So thank you so much for using Quarkus. Okay, so anyway, the session today about Quarkus is going to be very introductory to that. So maybe some of you are already using Quarkus, and some of these that are going to show you, maybe they're not news to you. But hopefully you'll be able to learn a thing or two, even if you're already a Quarkus user with this session. So I have a bunch of demos prepared to show you today. But before that, I will also like to go a little bit deep on what Quarkus actually is, if you haven't heard about it. And even for people that are using Quarkus, I'll probably want to speak a little bit about the internal details. So maybe you can understand a little better on how Quarkus works and what we actually do with Quarkus. So my name is Roberto Cortez. I'm actually work for Red Hat, and I work in the core of the Quarkus team. So this has been my life for the last, I guess, like 3 years. And I'm actually very happy to be able to work on Quarkus. Okay, so let's go and share the screen. And I should have here my slides. There you go. And this is actually a little bit weird. Not sure why. Let's do it like that. Okay. Oops. Yeah. There you go. Okay. So there's something weird going on with my browser, but we'll fix it out later. Okay, very well. What is Quarkus actually, right? So we like to say that Quarkus is just an open source stack that you're able to write any Java application. The idea with Quarkus is that you're able to write applications that are cloud native, microservices, or even serverless. But don't be hang out on these terms, because actually Quarkus is way more than that, and you can even write any other Java application that doesn't fall in these categories, right? So if you want to build a monolith with Quarkus, feel free to do it. If you want to build command line applications, Quarkus also works very well for those cases. But we bring these other topics because those were the use cases that we had in mind, and later on we were able to figure out that Quarkus was also able to do other use cases, right? Okay, so there are plenty of runtimes, there are plenty of frameworks, there are plenty of libraries in the Java ecosystem, and that's actually very good because it makes things going forward, and people like to have a choice on what they use. And I think it's also great because those technologies end up competing with each other. And of course, there's a lot of evolution, right? Innovation going on. So a natural question should be, well, why Quarkus? Why another framework tool? Why another library? Why should we care about Quarkus? Why should we use it? Right? And to answer that question, I have to go a little bit into some of the, well, high-level details on how the JVM works and how cloud native or cloud environments work in general, right? But if you look right now into how the JVM works and how usually it runs your Java application, right? You do have a overhead, startup overhead, right? Which is when the JVM will have to load a few classes, or depending on your application, may load a bunch of or a lot of classes into memory. And well, memory is just split in like multiple places, right? But one golden rule from JVM is once you load the class into the JVM, well, it's going to stay there forever, right? And yeah, when you have like a single class, I mean, it feels negative, doesn't feel like that's like heavyweight, right? But sometimes you end up loading a huge amount of classes that you only have like a single use for them. They just use like a single time, then they'll just, you don't gonna use them anymore, but they're gonna be still there consuming memory, right? So that's one point. The second point is, I mean, all of us, I believe at least all of us that are here, especially because this is the Java conference, all of us, we love Java, we love to develop in this ecosystem, but we also have to look into other ecosystems and figure out that things like Node and Go, right? They have more lightweight processes, and here I'm not going to discuss if a JVM is more performant or not than a Node process or a Go process. But in the end, at least if you just do like a very simple observation, you see that both Node and Go, they're gonna consume way less memory than a Java process, right? And this is bad, right? Because I mean, again, I don't want to start like a discussion about other implications about this, but if you go and do like a very simple analysis, right? So like people will just automatically say, oh, this consumes less memory, so it's way better, so let's use this, right? And we don't want to give that impression where yes, Java is like super heavyweight and is not able to compete with other technologies, especially in the cloud, right? If you think about it for a second, and this is why it became so much important in the last few years, think when you were running applications on bare metal, right? So usually when you have to run these applications, you'll go and you'll just buy some storage, buy like some hardware. And in most cases, because these took like very long approval processes, right? You ended up buying like a machine that had way more capacity than you actually needed, especially because upgrades were hard to do, right? And approving the money was also hard to do. And so in the end, you wouldn't care too much about memory and CPU because you'll have plenty of that available on whatever rack or whatever bare metal you were running with. On the cloud, it's a little bit different, right? Because on a cloud provider, you consume and you end up paying exactly what your application uses, right? So if an application will use CPU or use more memory, then that's going to reflect on your cloud costs, right? So the difference over here between bare metal and cloud is that you already paid upfront for a cost, so then you're not going to care too much about it. But on the cloud, you're going to pay as you go, and of course, you're going to care for what you're paying, right? Now, if you're able to actually reduce the memory consumption and the CPU consumption of a runtime, then that's going to be a direct benefit that you're going to get when you run things in the cloud. So that's one of the main motivators why we came up with Quarkus. So the idea with Quarkus is we try to come up with something that reduces the CPU and the memory usage, and I'm going to tell you exactly how. So these are not up to scale, right? But at least for what we've seen there is that we're able to fit way more Quarkus nodes than a traditional cloud native Java stack. And here we can count things like Wildfly or even Liberty or even Spring. I don't want to go into those topics directly, especially because other technologies are also doing something similar to compete in that space. But at least if you compare it to what we had like 5 or 10 years ago, that's at least what we want to do right now. So this is one angle, right? And we understand that while that is very exciting, or maybe it may be exciting for some people, maybe not exciting for some other people, right? I know it's really hard to come to a manager and say, hey, there's this new technology, it's way more performant, let's do, just going to change to that, right? So it's not the only argument. I mean, you can use it as an argument to move to a technology, but it's really hard to convince someone based on that argument alone, even if it's really, really good, right? So we also try to come up with other things that will make developers love the runtime that they're using to develop applications, right? So in that particular sense, we came up what we call like developer experience that you'll have when you're developing a Quarkus app, right? So first of all, we like to call these 4 different topics, right? And the first one is developer joy, right? So on developer joy, you have like zero config, reload time, right? So idea is that you don't have to configure your app. We'll try to come up with all these sensitive defaults for you, so you have like minimal configuration. You have our live reloading feature. It's some of the things that people love the most, right? So the idea is that with live reloading, you go in, you change your code, and you just hit refresh on your application, and Quarkus will hot reload the code for you, so you don't have to stop and start the server all the time, which it's really awesome, because one of the complaints that people have on our Java environment is one time when they have to do a change on their code, they have to stop the server and start again, and that takes time. People end up going and browse to a web page, and then they end up wasting like 10 minutes over there, and of course it's just going to interrupt their coding flow, right? Coming again to the performance, so here are a couple of numbers. So right now, if you pick up like a traditional application, just like a simple REST endpoint, we may be looking to maybe like 130 megs of memory usage. Well, on a Quarkus application, we usually see half the size. And when we compile it to native, and I'm also going to talk to native compilation a little more to the front of the presentation, you're going to see like memory sizes of like 10 meg, which is really impressive. Now, picking like a more complete example, and here we're talking like a REST endpoint or a few REST endpoints plus a CRUD, so database access, right? Where we just like creating, reading, updating, deleting some records, right? So a traditional native stack will see like 200 meg. Quarkus is not like half like we had on the previous example, but we'll still see like a very good improvement to like 50 meg. But if you see it on native image, now you'll see like again like only like a 10% usage of the compared to the JVM mode, right? So it's really something to look for. If you look on things like startup time, so startup time is also very impressive in my opinion, right? So on native, you're seeing like some millisecond startup time, right? So like 16 milliseconds on the first example, 42 milliseconds on the second one, right? But even on JVM mode, you'll see like sub-second startup time, right? So it will start really, really quick compared, of course, to the traditional native stack, which is very usual for people to start applications like 10, 15, 20, even more. I mean, I'm pretty sure all of you have worked on a Java application that had like something that required like a minute to start, right? So yeah, if you migrate something like that to Quarkus, I wouldn't say it's going to start in 2 seconds, but definitely it's going to not going to start in 1 minute. So it's going to take maybe like 10 seconds or even less than that. Now, one of the other things that we know that developers are now looking a lot is the reactive programming model, right? So we try to come up with a way to unify both worlds of interactive and reactive, right? So the idea is that you should be able to use the technology to fit your use case, but the programming model should not have to change if you want to use reactive stuff, right? So for instance, we do have here a couple of REST endpoints, and the one on the left is doing interactive programming, the other one is using reactive. And as you can see, there is no considerable differences between both programming models, right? So they're very similar. So the idea over here is if you want to change your application from imperative to reactive, you just change a couple of dependencies to use the reactive extensions of Quarkus, and you may have to adjust your endpoints here and there, of course, to use the proper constructs that reactive requires, but it shouldn't have to change dramatically that it seems that you're just writing a completely new application, right? Well, and finally, I mean, we don't want people to just have to come to Quarkus and try it and have to learn a complete new API, right? So the idea of Quarkus was we're just going to pick what's up on the community and we're just going to build on top of that, right? So we actually make a joke, right, when about this, especially you see this joke a lot on LinkedIn on recruiters when they come in and say they need like 5 or 10 years of experience on a particular technology is only like 2 years old, right? And you most likely gonna make fun of that. But in here is actually the case, right? Because Quarkus is only like 3-4 years old, but most likely you're gonna have like 10 years of experience in Quarkus or even more. And the reason for this is because you're not going to have to learn any new technology to build a Quarkus application. All of the APIs are already that you can use to build a Quarkus app. We just reuse what's in the community. So we use things like REST Easy, which is JavaPro, Hibernate, Vertex, MicroProfile, right? Even if you're coming from the Spring world, we do support I will not say all the Spring APIs, but we support like most of the popular Spring APIs. So you can write the Quarkus application using Spring or the Spring API. So it's not going to run Spring, but the APIs that you'll use are going to be exactly the same. So this brings like a sense of familiarity and the bar to get in developer Quarkus applications really low, because I mean the APIs you already know them. So you can just start coding. Of course, we do offer selected Quarkus APIs, and the reason we do that is, of course, to try to improve a few things and well, try to simplify a couple of other things. Okay, so this seems very exciting, I hope. But how does Quarkus work internally? So for you to understand on how we're able to offer all of this to you. So a traditional framework, how does it work? So usually what you have is you create your application, right? And you have to go for a build process, can be like Maven or Gradle, right? From that build process, you'll generate a jar file or a WAR file. And then that file you have on your application, gonna hand it over to a runtime. And then the runtime is gonna just pick that up, it's gonna extract it, and then it's gonna perform a bunch of operations on that, right? So it's going to start reading, let's just say, may read configuration, may parse it. It's going to like scan your class path for annotations to enhance your classes, right? It may just say if you have a path annotation or the Spring one, can't remember which one it is, but it's going to look for those annotations, right, to create a REST endpoint. So all of that happens in runtime, and it takes time, right? It takes memory. And if you know a link to what I said earlier, where you think, okay, you load a class into the JVM and that gets loaded forever, right? So a lot of this code is only executed when you're starting up your application, right? And then there is no use for that anymore. So it's just wasted memory and wasted time all over the place. Now with Quarkus, what we did is we just did the other way around, right? So we try, the idea with Quarkus is we try to do as many operations as possible during compilation time. So when we start on runtime, most of the operations are already done, and the end, or what you're going to gain with that is it's going to be less memory and it's going to be less CPU. Because I mean there is less startup time because most of those operations were already executed. So I think it's grasping this concept, and I mean, I haven't talked anything of how we do it internally exactly, but I think this makes sense, right? This also has like another interesting side effect that maybe you haven't considered, right? But think how much wasted runtimes do we have when we're running things into the cloud and we have to run them, like let's just say 100 nodes, right? So most likely you're going to run the same application those 100 nodes, right? Because I mean, you're scaling your stuff and you may need 100 or maybe more or even less, but all the operations that are going to be executed on every node is going to be exactly the same, right? So it's going to be a waste of processing power on that time. But you only need one compilation, right? Which is going to serve all the nodes. So of course there's going to be interest of you to try to concentrate as many operations during compilation time, because that's only one time that you're going to have to pay the price, and you don't want to pay the price 100 times, right? So that's an interesting side effect. Okay, so if we agree that this is a good thing, right, and try to move as much as possible to the build phase, there are a couple other things now that you can actually make, right? So we can reduce the number of runtime dependencies, right? So if, let's just say, you require a dependency to do class path scanning to search for, let's just say, a path annotation, right? If you search for that path annotation during compilation time and you already know what it is, well, you're not going to need that code anymore. So you can just throw it away. I mean, it's not going to even load during runtime. So those are and we do a lot of other optimizations. So those are just something to have in mind on what we do. And one of the end goals for this was actually, of course, to be able to build for native, right? I'm going to get into that. So when you want to build something using RHEL VM to native, there is a bunch of other limitations. And a lot of this work that we do during build time help us to have a more optimized application and a runtime to be able to build it with native, right? Now you may be asking, well, isn't my build time going to increase? Well, sure, yes, but as we've seen, it's not very noticeable, right? Especially because we only do things a single time. So another example. So it's very natural in runtime. You're going to have like multiple class path scannings happening, right? Because every library doesn't know if the other library is over there. So most of the time they're going to implement their own class path scanning. So one of the things that we do is we'll just scan the class path like a single time, and we'll just hand over to each library where everything is. So we do save a lot of time even on compilation by doing these kind of optimization. So you're not going to notice like a very high compilation time, even if you're doing more operations that a normal Java application being compiled doesn't have to worry about. Okay, so again, these are just a couple of other examples that an application does on startup time, right? So as you know, Java is very high on things like reflection and proxy building. So that's another thing that we do, is we try to remove as much reflection and proxies as possible, right? So if you look and see there's like a reflection call at some point, we can just go over there and we can just replace it with direct bytecode directly on that method call, or whatever call has to be done over there, right? So yes, reflection is great. It allows Java language to do such amazing things, but there is a price that you pay for reflection. And most of the times, I mean, you don't care about it, but nothing is going to beat like a direct method call if you compare it to reflection, right? And all of these things that I'm talking about, I mean, they seem like very small, but when you start adding them together, right? So you have like one bit over here, one bit over there, right? They're just going to pile up, and then they're going to be considerably a huge improvement for your app. So in conclusion, the idea is, I mean, we do the work once, not in each start, right? And it's not only when you're running your application on the cloud on 100 nodes, such as so you have to restart, then you have to redo all things all over again. Much of the bootstrap classes are not longer loaded, right? So let's just say you need to load an XML file. Well, if you can read the XML file during build time, then you just can drop all the XML parsers. You don't need them anymore. So I think that it's really easy to understand that with all of these optimizations, of course, you're going to have less time to start because there's less things to load into memory, and yes, there's going to be less memory use. And because of some optimization we also do under reflection and dynamic proxies, that's also going to be much faster for you to run your application and even to start it up. So all of these optimizations, of course, is going to be the benefit on the cloud, again, because of what we explained earlier, where you have to pay cloud costs by the CPU and memory, right? So if you have a runtime that's able to save on memory and save on CPU, well, you're going to save money completely directly just by using that runtime. So how do we actually do this, right? So what we did is we create this concept of Quarkus extensions, right? And an extension pretty much wraps the original library that we want to integrate into Quarkus. So Quarkus does work with any Java library out there. So you can put it everywhere. You can use any library in Quarkus. It will still Java, it still will work. Now, what we recommend, of course, is we'll use the Quarkus extensions that we make available for you, because those are the pieces that are going to contain the optimizations that we do, right? If you just add like a simple library onto Quarkus, the library usually is not aware of a build time or a compile time and a runtime time processing environment, right? So the extension itself is the one that we just tell the library, okay, we're just going to start this for you during build time, and then we'll hand over this to you over runtime. So the extension is where all of that magic happens, but they are not mandatory, right? So you can use whatever library you want with Quarkus. It will still work completely out of the box. It's just that it's the extension that's going to provide a lot of this magic. Now, you may be hearing or maybe seeing that, well, if Quarkus is just an heavy compiler, or maybe it's just for Kubernetes or just for small applications. Well, I'll have to say I disagree. I think Quarkus is way more than that. So you can use it for a lot of other things, right? So we've seen like people using it for building CLI applications, even running things on Raspberry Pis, which is really great, because since the runtime is so lightweight, it's really perfect for those kind of devices. Okay, so native image. So maybe you heard about something called GraalVM before. So if you haven't, I'm just going to briefly explain it. So GraalVM is a VM coming from Oracle. It's already maybe like 4 or 5 years old. I can't remember exactly. But one of the exciting things about GraalVM is that GraalVM is able to pick up your Java application and create a native executable out of it. So meaning that you're not going to run a Java application in the JVM. It's just going to be like a plain executable app. So there's still a VM involved, which is called Substrat VM. But there, of course, there are considerable differences between one and the other. But as you can probably think about it, I mean, when you're building something to native, or you're building something to an executable, you require this closed world assumption, right? So how are you going to load things dynamically, right? So that's simply not possible. I mean, or it could be possible, but because you don't know what you're going to have to load, then you're going to have to include the entire JVM, the entire dependency tree that you have. And well, in the end, you're going to end up with a executable of, I don't know, a few hundred megs. And that's not what we intended, right? What we intend is to have like a very small, lightweight binary that you can execute. So for this, there are of course things that are not supported when you're building to native, right? So things like dynamic class loading, which is probably the most problematic stuff. So that's why we try to remove a lot of these things from Quarkus, and that's again, that's where what we do on extensions, right? We try to work around the libraries to handle this for you. But there are other things that even if they are supported, they have a few limitations, right? So for instance, reflection, yes, it is supported, but you have to tell exactly what are the reflection calls that you're going to require. And the reason for this, right, if that's not limited, again, you'll have to include everything because you don't know what reflection call is going to happen on runtime. So that's why we try to remove as much as we can from reflection when we're building the application. Okay, so you may be wondering, yeah, I mean, that's great. You have like, you're able to run Quarkus on both a JVM or a native image. So you may be wondering and asking, well, where should I run one or the other? And the idea is, if you still have like these, at least for now, of course, GraalVM is improving every day. We're not sure if it's going to come to a point where it's going to be better than the regular JVM for these scenarios. But if you have like higher heap sizes and if you need like the best throughput, right? So it's still going to be a JVM with the JIT compiler that's going to achieve that for you. But in other cases, right, when you need like a really fast startup time, like I've shown you on some of the numbers before, maybe like serverless, or even like command line applications, or if you have like really low heap sizes, well, the native image really shines in these areas. So that's a place where you can use them. And I mean, nothing's stopping you to, and again, it's going to be very tricky to answer if your application should be run on the JVM or on the native image. But what we can be sure is that Quarkus gives you an environment where everything is going to work exactly the same in both places, right? So you can even have like a couple of nodes running on the JVM, a couple of other nodes running on native image, and you can even like compare both and see what works best for you. But that's usually my recommendation. Okay, so enough of theoretical talk. Let me show you some Quarkus stuff. I hope this was not too boring, but I like to do these few slides for at least for newcomers and for new people to understand a bit of the internals. And even if you're already using Quarkus, maybe you were not completely aware on how we do stuff internally, and I think that at least you get like a better picture on what's happening under the covers. Okay, so let's go here to my IDE. Okay, so I have here a sample project. One of the things is you're gonna find this project on GitHub, so you can use it if you want. That's completely fine. One of the things that you may want to look for is if you want to start a new Quarkus app, you have this website called Quarkus.io. So I'm not gonna do something here right now, but basically you just, oops, sorry. So you come over here, you'll just pick whatever technology you want to use, and then pick generate, and this is just going to generate a Quarkus application for you, and you can just bootstrap it and start it from your IDE. But in here, I really want to show you like my Quarkus application that I already have. So it's something very simple for now. I have like a couple of microservices here. I'm just going to start with the first one. This is what we like to just put this like in full screen so you can see it better. There you go. And the first thing I'm going to show you is just the POM file. So this also works with Gradle, just like an old-fashioned guy in like XML. But as you can see, there is no big differences. The only secret that you have here is just the extensions that are using the Quarkus namespace, right? So those are coming from Quarkus. But we also have a few others that are not coming from Quarkus, like Rest Assured, like that's over here. So there is nothing really out of the ordinary on the POM file, just the dependencies. And in here is I have a couple of classes. So here is a service, and here is my REST endpoint. So I think probably most of you already seen this code in the past, or even if you like a Spring developer and not using like Javax now Jakarta stuff, this will be very similar. So I'm going to do something for you to see. Is I'm going to search for Quarkus, and the only thing that you actually see is Quarkus on package declarations, because that's how I name my project. But you don't see any Quarkus APIs being used. So all of these are like that I have are like things from Eclipse micro profiles, things from Javax, right? So this very familiar. And yeah, so let's I'm going to start this Quarkus application. So this is this module, and I'm going to do something which is going to start Quarkus in development mode. So Quarkus in development mode is what you should be using to develop your Quarkus application, right? So this is what it's going to look for your app. It's going to bootstrap everything for you. And now the application already started, so I'm able to call a couple of REST endpoints over here. And let's do like a couple of curls. So yeah, so this just generating like a random number. This is actually like an ESPN to create books. I'm gonna get into that detail in a sec. But yeah, I have a bunch of them, so that's working fine. But now let's just say, yeah, I want to change my application, right? So you can just over here, and well, let's just create like a new method. I'll say hello JCon, and well, just return hello JCon. Well, this is not the REST endpoint yet because I have these on an interface. So let's just put that over here as well. String hello JCon, right? And this is a path, and I'm just going to say, well, path hello, right? And I think that's pretty much it, right? So yeah, so if I come over here and I'll just say hello. Maybe I missed something. Let me see. Oh, I think I'm missing. Yeah, sorry. So it's using position reference because I need to put the method name. Yeah. Sorry about that. Oops, not this one. And there you go. Now you have like a low JCon, right? And as you've seen, I haven't changed the code at all. So I can even come over here on my browser if I want and say HTTPS localhost 2090, and I'm going to show a few other things. So here you have the development console, right? It's going to be available for you, right? So there is a bunch of things that you can look for over here. So all the extensions that are loaded by Quarkus, you have them here, and including OpenAPI. So you can see like the endpoints that are running over there. I don't have sorry yet because I didn't load it over here, but I'm going to show you that on another app. But if I go and call hello, well, you have hello JCon, and then now I can just keep changing the code as much as I want. And well, I'll just hit refresh, and as you can see, it was like super fast, right? So these like a couple of things that people really enjoy about it. But now let's go and move to something a little more tricky, right? So now I'm going to start another service, right? This is called Book API. If I show the code a little bit, now you'll see there is a bunch of other things over here. So there is persistence. So you'll see there is like an entity manager over here. So he's actually using JPA. There is a couple of REST endpoints, right? Here is my entity over here, which is a book, right? Now, naturally, what you want is, well, you have JPA, so you need a database, right? So I have to start a database, right? That's what you'll think of. Well, not with Quarkus. So I'm going to run Quarkus again in Quarkus dev. And not what you're going to see that Quarkus is going to do is Quarkus is going to look into your application and see, oh, you need a database, but you don't have one available. So Quarkus is automatically bootstrap one for you using test containers. And the idea here over here is that you're not going to fail your application start because Quarkus or because you don't have a database, right? So the idea here is Quarkus will search for the services that are required on your application. And if it doesn't find them, it's just going to bootstrap them for you on the context of these of Quarkus dev. Once you stop Quarkus dev, well, they're just going to trash the services and you're done. And this creates like a very interesting development environment because then you don't have to figure out or don't have to worry about bootstrapping all these services first and then running your application and then developing and then stopping things down. So I think this is really cool. And if you notice over here, it was not only the database that started up, right? So it's also started up Kafka queues, right? Because I'm also running Kafka over here. And if I go here to my browser again, now you'll see on that one, there's a bunch of things here. So those are the endpoints that you have, and I should have Swagger UI here now. So we add a lot of stuff to help help you to, of course, being productive on developing stuff. Now, one of the other cool things that we have, as you maybe have noticed over here, is there is like something saying here like test pauses, right? So let me just resume them. Right, then you'll see like, oh, there's like free test passing. So what is this, right? So this is actually a feature we call continuous testing. So the thing, I mean, this is disabled once you start the app, but you can resume them. And what's going to happen is you have some tests over here, right? And if you change, let me see. So the test that we're running. So let's go here to test, right? And I believe this is probably the test that's being executed. So if I come and start to change, I'll just say, so this is the assert that's being done. And if I change something over here, like an X, now you'll see that this fails, right? So what's happening over here is that I'm changing my test, I'm changing my code, and the tests are being executed when I change my code as well. I think that was now you'll see that all the tests are passing again. So everything is cool. So the idea with this feature is you can just be on your development zone, you just hit your code, develop things, and you'll automatically get quick feedback. You don't even have to run the tests. So in here, it's just like I have like a single test class, but Quark is actually smart enough to understand which code you change is to only run the tests that are affected by that code change, right? So meaning that not every test is going to be executed all the time to change the code, because of course it's going to be, you may have a lot of tests, and of course this is what you expect when you're developing a real application, and you don't want to run all the tests all the time. So Quarkus is able to figure out which tests have to be executed. So it's only going to run those tests for you, and just going to give you like very quick feedback when that happens. So that's one thing that you can do. So I'm just going to stop this for now. So we show you a development mode. We show you continuous testing. I show you bootstrapping services that we require. We call that dev services, right? So it can be applied to things like databases, Kafka queues, keycloak instances, you name it. So let me see what else do I want to show you that we have over here. I think we still have 5 minutes left, right? So of course I can show you the native image, right? And this is going to take a little bit, but I just want to show how that works. So I'm just going to build the app, and I'm just going to pass in a profile. This is going to say native, and this is going to build the application as native, right? So this is the time where you just go and drink some coffee, right? Because I mean, if you remember, if you've been an old developer like me, and you don't even have to be old, but if you have some experience building C applications, right? You know how much the C compiler takes to compile something, because in here we're not doing bytecode anymore, right? We're just, the compiler is actually having to analyze all the code to be able to generate the native image or the native executable. So this is going to take some time. The idea over here with Quarkus is you should not be doing this all the time. You develop your Quarkus application with the regular dev mode and regular JUnit testing, right? And once you're happy with that, then you just build it to native and you can just run it. So the recommendation over here is that you can even have your continuous integration environment to do this for you once you're happy with whatever code you're working on. What we assure you is everything that works on JVM is also going to work on native image. And if it doesn't work, then it is a bug, and it should come and report it to us, and we'll of course going to fix it. So now that's done. Just took like 26 seconds. And I'm going to do something that you'll never do, right? So I'm just going to go and cat something called here number API runner. Actually, let me do like an ls first. So you'll see that there's number API runner. It's 58 meg. So let's do a cat over that. And well, you see this is completely binary, right? So how do you run binary stuff, right? You'll do like .flash, at least over here. And yeah, here we go. Completely binary application running. It started in 35 milliseconds, right? And if I go, I'll probably monitor this just easier over here. And this is not Java anymore, so I have to search for actually the process name. So now you'll see there is like a number API running is like only 18 megs in memory. So that's pretty amazing. So that's native image. And we only have a couple of minutes left. There's a bunch of other things that I would like to show you, but please feel free to go into that GitHub repo and search for stuff, because I want to keep the last extra minutes that we have to see if we have any QA for me to reply to. So let's go over here. Let me stop sharing. And let's see what questions do we have. So we have a question from Maurice. So recognizing the deltas in such a quick time really sounds cool. So will you recommend to use Quarkus on legacy Spring applications? Are there limitations on when not to use it? Yes, there are no limitations. The only limitations that you may have is maybe there are APIs that we don't support. So let me actually, that's probably the last demo that I wanted to do. So let me do one which is really quick demo. I don't even have to code that. Let me just do a rollback on this. And I have these shelf files over here. So this one. So this is let me just import this. So this is Spring code, right? All of you recognize this. So this is like Spring code. The only thing that I did is I added this interface or this class, and then there is this API extension, which is the Spring extensions for Quarkus. And if I run that, and I run that with Quarkus dev, I know I haven't downloaded that for a while. But I have that mapping for Spring on numbers, not on 1890, so 1890/numbers greeting, or just greetings actually. Sorry. Just wanted to. There you go. Oh, that's still on an old presentation that I did. But now I can just come here on my Spring and say JCon. And what do you think is going to happen? Well, I reload and you have, so now you have like hot reloading on Spring code when you're running things into Quarkus. So that's something you can do as well. So to keep answering that question, right? So feel free to use things on Spring. The only limitation that you may have is we don't support the entire Spring API. We only support the most popular stuff like MVCs and some of the data stuff and a bunch of other things. So if you're using Spring stuff you don't support, well, you can just come and ask us and we'll try to implement that for you. So another question is there any recommended framework for this? Also coming from Moss. Is there any recommended framework for developing a full stack web app with Quarkus, including MVC architecture with server-side rendering? Yes, we do have things that allow you. So we have this template engine called Qt. We also have something called Quinoa, which help you developing these full web stack applications. So feel free to look into that. And people seem to be happy with that. So that definitely works. But you can use Quarkus as a server-side only and use something else for the web UI. That's completely fine. So we have something from Gazi now, saying Javi plus microprofile JSF. I think that was the answer for the previous question from Gazi. So thank you so much for helping answer that. From Dirk, and that was a person that I was seeing before. So thank you so much for the presentation earlier and for using Quarkus. So the question is, will Quarkus adopt J10, Jakarta namespace? Yes, it will. Well, we hope that's going to happen the next couple of months. So right now, as you can imagine, I mean, this JavaX Jakarta rename is being like a complete nightmare for every person and every library on the ecosystem, right? And especially for Quarkus, because on the Quarkus side, we need to make sure that every library has made the update for us to be able to update, right? Because then if they haven't done, then it's not going to work. So right now we have a branch that you can use if you want. We have daily builds where we're just building things with Jakarta. And for now, it's only Jakarta 9 because Jakarta 10 only came out like a couple of weeks ago. But the idea here is we're going to do, when we do the Jakarta jump, it's going to be directly to Jakarta 10. And while we cannot compromise with the date yet, we hope that in the next couple of months, we will have a Jakarta 10 ready Quarkus final that you can use. But again, it's a very hard process because we need to make sure that every library already made the update for us to do that jump again. But that's something that we're working on, and yes, we'll definitely support that. So I think that we don't have any other questions. So yeah, so thank you so much for joining me today. I hope that you enjoy the presentation. I hope that you enjoy what you've seen. If you have any other Quarkus questions, please feel free to look me up on Twitter or on Zulip web chat. So Quarkus has a Zulip web chat that you can find on GitHub. I'll be happy to help, and you can just pick up that GitHub repo. I can just put that on the chat as well from where I've done the demos, and you can just pick that up and do a bunch of other demos that you have instructions over there, so you can do them yourself and play with that. So thank you so much for joining today, and I hope that you enjoy the rest of the conference.